In today's lesson, we are going to be looking at the transformations of sine and cosine waves. So we touched on them briefly in the previous lesson, and we're just going to look at them a little bit further in this lesson. And we're also going to look at kind of a reverse transformations in the sense of if we're given some descriptions of transformations, can we come up with the graphs or come up with the equations? So first, let's just review sine and cosine functions. All right. So again, we talked about the general functions and how they look, and we talked about the a, k, d, and c values. Specifically, we talked about the new components or the new characteristics that are determined or mentioned or referenced by these variables. So a also tells us the amplitude, and we can use the k value to help us determine what the period of our sine or cosine wave is. Right? The a, k, d, and c in terms of the general transformations, that is going to be the same as all the other transformations we've looked at. But the a and the k telling us the amplitude and helping us determine the period was new. Now, with all of our transformations, we need to have our parent functions. Right? So we need to have our parent functions, and we did graph these functions in the previous lessons. And yes, there were quite a lot of values. I think we did every 30 degrees. We looked at finding the what the related value was in sine and cosine. However, there are really only about 6 key points, 5 or 6 key points that we need to use when looking at sine and cosine. So for sine, so for our sine wave, right, we're going to look at 0, 90, 180, 270, and 360. So we can reference back to the previous lesson if you want, or you can just enter in sine of 0 and see what we get. We end up with 0, 1, 0, negative 1, and 0. So when we graph that, we get a nice looking sine wave. That looks something, if I can hit all the points, something like this. And those are the only points we really need, because then it starts to repeat that pattern, right? It is a periodic function, so this starts to repeat. So basically every 90 degrees, we're going to see this kind of repetition of going up to 1, back to 0, down to negative 1, back up to 0, up to 1, and so on and so on and so on. So we really only need these 5 key points to help us with our transformations. Now cosine, again, similar idea, cosine x, right? We had a bunch of values. We did every 30 degrees. But here we don't really need, again, all of those values. I only need these 5 points, right? These key points to help us at least get a general idea of what the function is, or at least to help us come up with the image points. So for cosine of 0, we had 1, and then 0, negative 1, 0, and 1. So similar values to our sine wave, except it's a slightly different portion of it, right? We're starting at 1, we're starting at our maximum, so to speak, rather than the midline. So it does look a little bit different, but it's the same values, just a different segment, right? It still has a period of 360 degrees. It still has the same amplitude. It still has the same max and min, right? Just kind of a different portion. We'll talk about how they're kind of related in the next lesson or a little bit later on. But again, we just want to make sure we know the key points, because that will help us with our transformations. So now we're going to look at graphing the transformed sinusoidal functions. So sinusoidal is just a term referring to either our sine or cosine waves. those periodic functions. And we're going to try to graph this transformed function y equals 2 sine x plus 1. And we're going to go through the same process as other transformed functions, right? We're going to have our key points. We're going to come up with the image points using our mapping notation. And then we're also going to state the amplitude, the period, the number of cycles between 0 and 360, as well as graphing it. So it is a sine function. We see the sine x, so that is going to mean that our key points or our parent function is going to be the sine wave one. So 0, 90, 180, 270, 360. And the sine wave was the one that starts at the midline. So we start at 0, we go up to 1, we come back to 0, we go down to -1, and we come back up to 0. So if we wanted to see what that looks like, right, again, just a reminder, so it looks something like this. And I can repeat that if I want, because again, it's a periodic function, so it's going to continue that pattern of going up and down. So I can continue that. So that's my parent function. For my transformed function, y equals 2 sine x plus 1, I need to figure out what my values are and come up with my mapping notation. Now the mapping notation is going to be the same, right? It's going to be, what is this, if I can remember, x over k plus d, and it's going to be ay plus c. So I need to figure out what variables I have or what transformations I have. I see a 2 out front, so that is an a value. I don't see anything attached to the x, but I do see a +1 after, which would be my c value. That means for my image points, nothing's going to change with the x. It's still going to be 0, 90, 180, 270, and 360. My y value, though, is going to, there is going to be some mapping notation for that, because I have 2 for a and 1 for c. So this becomes 2y plus 1 for our mapping notation. Let me actually just change these colors just to keep it consistent with the transform function. So I'm going to take my y values, apply these transformations to them. So 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. 0 times 2 is 0, plus 1 is 1. -1 times 2 is -2, plus 1 is -1. And then 0, right, we've had that value before, so it's 1. So now what I can do, I can graph my, my transformed function. So at 0, it's 1. At 90, it's 3. At 180, it's 1. At 270, it's -1. And at 360, it's 1. So this is my transformed function. And again, I could continue this pattern if I wanted to. Every 90 degrees for this specific function. And this would be my transformed function, the 2 sine x plus 1. Now, do we know, we want to basically then now figure out our amplitude, the period, and the number of cycles between 0 and 360. So the amplitude first is half the distance between the maximum and the minimum, right? So our maximum is going to equal 3. The minimum is going to equal -1. So our amplitude is 3 minus -1 divided by 2, or 2, right? Or 4, well, 4 divided by 2, or 2. So that means that the amplitude is here. So this is 2 units, this is 2 units. And the amplitude, we talked a little bit about it in the previous lesson, but the amplitude is, yes, it's half the distance between the max and the min, but it's also the distance between the max and min from the midline. So with our sine and cosine wave, there is going to be a midline. And the midline is basically an imaginary line that cuts our function in half. So this is our midline. And what do we notice about that midline? Well, the midline is at 1. And where else do we see that? Looking at our function, where else do we see a 1? Well, in our function, we see that the 1 is our c value. So the midline is actually what our c value is. So from our function, we can get what our midline is. The period is the length of one cycle. So I'm basically looking for where do my values repeat, or where does the pattern repeat. Right? So I can start at 1 here. I go to 1, but my pattern goes downward, so I'm not quite done yet. I go over here to where my pattern comes up. So this is 1 period. I could also figure it out because if I go back up, all the way back up, all the way back up, the period can be determined from the k value, right? 360 divided by k equals the period. I could have also determined the a value from the amplitude from the a value in our function, because the a value was 2, so the amplitude is 2. The period is 360 divided by k, or the absolute value of k. The k value here, we don't see it, so we can assume that it's 1. So 360 divided by 1 equals 360 degrees, which we also see visually as well. So how many cycles are there between 0 and 360? Well, there is one cycle. And where do I see this? Well, if I'm using the k value to divide 360 by, to tell me what the period is, or the length of one cycle, then the k value is actually going to tell me the number of cycles. So the absolute value of k is equal to the number of cycles. So if I know the k value, I know the number of cycles, I can determine the period. If I know the a value, I can determine what the amplitude is. If I know the c value, I can determine the midline. Right, so there's a lot of characteristics of my sine wave or cosine wave that I can get from the function itself, even without graphing it. For our next example, we want to graph y equals negative 1.5 cosine in brackets 3 times x minus 30 in brackets plus 5. So a little bit more complex, and we're dealing with our cosine function. Now that doesn't really change much in terms of the transformations except for our different parent function. We're still dealing with 0, 90, 180, 270, and 360. The y values are a little bit different, but again, we know what our key points are because we've already graphed them at the beginning, so you might want to refer back to that. We start at 0, or 1, we go down to 0, down to -1, back up to 0, and then continuing up to 1, and then we would end up coming down. So I'm going to graph this one just so we have, again, an idea of what this looks like. This one is not the nicest because of our scales, but we'll make do. 90, 180, 270, 360. So we see it's more of this just kind of up and down shape. For our cosine function, our cosine wave. And again, I could draw the same thing on the other side. If I wanted to see another cycle of it, right? Because it's going to be the same type of function, or because it's that periodic behavior. Oops, not sine, sorry. It is cosine x. So this is what our cosine function looks like, our general parent function. Now I want to go through and come up with my mapping notation to help me create my image points. So I have an A value, a K value, a D value, and a C value. So I have one of every value. So for my mapping notation, it's going to be x divided by k, or x over 3, plus d, so plus 30, because again, opposite of what we see, so the d value is actually positive 30. For my y value, it's going to be negative 1.5y plus 0.5. So when I plug the values in, or my parent values, for x, 0 divided by 3 plus 30 is 30. 90 divided by 30 is 30, plus 30 is 60. 180 divided by 30, or divided by 3 is 60, plus 30 is 90. So we can see what's happening with our values, right? They're increasing by 30. So we have then 120 and 150. So those are the x values. For our y values, 1 times negative 0.5 is negative 0.5, plus 0.5 is negative 1. 0.5, because 0 times anything is 0, plus 0.5 is 0.5. Negative 1 times negative 1.5 is positive 1.5, plus 0.5 is 2. We've already determined 0 before, which is 0.5. And we've determined 1 before, which is negative 1. So let's take these values. Let me change the color just so we can kind of keep it consistent. Let's change the colors. Let's go through and graph these points. So at 30 and negative 1. So 30 and negative 1. We're then at 60 and 0.5. 90 and 2. 120 and 0.5. And 150 and negative 1. So there's one cycle of our function, right? And I can continue this, and it's going to repeat every 30 centimeters. So at 180, it's going to go back up to 0.5. At 210, it's going to go up to 2, and we just start to repeat this pattern. So it is really straightforward once we kind of have at least one cycle. We just start kind of repeating our values, or at least the y values, over a set period of x values. And I can continue this. So then, again, getting this kind of sine wave, or cosine wave more specifically. And you want, when you're doing it, you want to make sure that it's kind of rounded or curved at the point. You don't want to make it straight lines, because when we graphed the parent functions, or when we looked at the actual values, it's not like a linear pattern or a linear line, right? It's kind of like a gradual. It gets steeper, and then it slows down, and then it gets gradually faster or higher, and then slows down depending as we get to the max and the min. Just want to be careful of that. So this is negative 1.5 cosine of 3x minus 30 plus 0.5. So you don't really need to show that. I'm just labeling my two lines. I do have my midline. If I wanted to draw that, I do have my midline going across. I get that. That's my C value as well. So I have my midline, or C equals 0.5. If I wanted to see that. I also want to determine my amplitude, my period, and the number of cycles between 0 and 360. Amplitude is easy because the amplitude is the A value, or the absolute value of A. In this case, it means the absolute value of negative 1.5, which just means 1.5. Basically, the absolute value just basically means the positive, only the positive version. So because it's negative 1.5, the amplitude is just 1.5. And we can see that from the graph because we can see what our highest value is. We could determine it by looking at the distance from the midline to the maximum, or from 0.5 to 2, or from 0.5 down to our minimum, which is 1. So different ways you could look at it. I could take the max and min as well. So 2 minus negative 1 divided by 2, or 3 divided by 2, which is 1.5. So different ways you can determine the A value. The period, if I wanted to, again, I could look at one cycle. This one's not too bad because I have maximum and minimum values to look at. So from here to here, so this was 30 to 150. So my period would be 120 degrees. I could also determine it algebraically because we had 360 divided by the absolute value of k. K in this case is 3. So 360 divided by 3 equals 120. So again, different ways we could determine it. If we wanted to graph it, we would be able to see it visually. If I didn't, I could also determine it algebraically. For the number of cycles, again, I could look at 360 degrees, right? If I highlight it and say, okay, so I have 1 cycle, 2 cycles, 3 cycles, right? So I could look at it that way, visually, seeing the different cycles. Right? We can see them kind of coming in here. So 1, 2, 3. So 3 cycles. So that means number of cycles. I could also determine that because that is the absolute value of k, right? So I know my k value is 3. That is also the number of cycles. So different ways we could look at, trying to determine, I'm just going to erase these highlight marks, hopefully. Nope. I'll leave one cycle highlighted. So different ways we can determine it, whether we're looking at the graph visually or algebraically without graphing it. So now that we've looked at graphing and transformed function, now we're going to look at trying to determine the equation of a sine or cosine function given its graph. Right? So it's not likely that we're just going to be every kind of periodic behavior when we're dealing with sine and cosine waves is going to be exactly the same as the parent function. It's probably going to be transformed, right? It's going to be either more periods or increased amplitude or something along those lines. So if we're given a function or given a sine or cosine wave, we want to be able to determine the function for it. So the steps that we're going to look at first we want to find the max and minimum value. If I can find the max and minimum value, right, I can then determine the amplitude of the function or the a value. I can find the vertical shift, right, which is the c value, by doing the max minus the amplitude. Right, this is again the middle of the function or the midline. Right, so that c value is the midline. So if I subtract the amplitude from the maximum, I'm going to get to what my midline is. Next, I'm going to look for the period. So the period I can find by using a starting point and an ending point of a full cycle. So this one, because we're given the graphs, we would be able to visually see what the period is. And then in doing so, I can kind of work backwards to figure out the k value. I can do 360 divided by the period to tell me the k value, or basically see how many cycles are there between 0 and 360. Finally, I'm going to look for the phase shift, or the d value. Now this one there's no kind of fancy way to do this. you're basically starting at the y-axis. For sine, you're going to move from the y-axis to the bottom left of the closest rising portion of the midline. Right? So if we look on our graph here, we start at our y-axis, we move till we hit the increasing portion at the midline, or the first time we do that. For cosine, we're moving from the y-axis to the right to our closest maximum value, right? So which would be up here. Right? And again, that's just because based on the characteristics of how our sine and cosine functions start. Right? Remember, the sine function started at our midline, or 0, and the cosine function started at our maximum. So let's go through a couple of examples and try to determine the equation for both the sine and cosine functions, or depending on, or a sinusoidal function. So it might not just be sine, it might be both, or maybe it's just one. So for our first example, we want to find or determine the equation of a sine and cosine function that represents each graph. So the first thing I'm going to do is find my amplitude. Right, so I'm going to find my maximum value and my minimum value, which I can clearly see the high and the low points. So my amplitude, A, is going to equal the max minus the min divided by 2, or 3 minus -1 divided by 2, 4 divided by 2, or 2. So my A value here is going to be 2. Next, I'm going to look for, could find the midline, right? So my midline, or my C value, is going to equal the maximum minus A, right, or the absolute value of A, which is going to be 3 minus 2, which equals 1. Which does make sense, because if my amplitude is 2, then that's going to bring me to my midline, which is my C value. So I have my A value, I have my C value. Next, I'm going to look for is my period, or the K value. So for the K value, first I want to find the period. So I could go from a max to a max. So I'm going to go here to here. Right? I could go from a minimum to a minimum. We talked about it before. There's different points that we could use within a cycle to determine the period. So I'm going to use my two maximums here to determine my period. So this goes from 20 to 30. So that means that the period is 10. So for the K value, it would be 360 divided by the period, or 360 divided by 10, which is 36. Which would mean that there are 36 cycles in 360 degrees. Lastly, for my D value. So I have two different D values. So I have D value for sine, and we'll use purple. I have a D value for cosine. The D value for sine, remember we said, was going from, let me use a different color for this, or I can use it. We said that we start at the y-axis and we go over until we hit the rising portion, going up to our max from the midline. So if I go over and then I hit the rising portion here. So this distance is my the D value for sine. So in this case, it is, if I look at it, there's 4, so that is 7.5. For cosine, the D value, I start at the y-axis and I go over until I hit the maximum, or the first maximum, which is 10. for my two functions, right, I'm going to start with the sine. So y equals a, which is 2 sine, and then in brackets 36 x, because it's positive, x minus 7.5 plus my c value, or plus 1. So that is my sine function. Now the cosine function for the same graph, or the same graph, is going to be almost exactly the same. Y equals 2 cosine 360, except it's going to be x minus 10 plus 1. Now you might be saying, well, aren't there other ones that I could be doing? Like, aren't there different ones? Could I not maybe do a reflected version of this? And yes, there are. There are many different ways that you could write these different functions, right? Because maybe you say that this value here is the rising portion, but it's just been vertically reflected. So you could do that as well. Right? So there are different ways that you could determine or different functions that you could come up with, just with the nature of just with the periodic nature of these graphs. But we're kind of stick to these patterns just so we're kind of consistent with coming up with these equations. But yes, there are different ones that you could use. Maybe you don't look at the first one, you look at the second one. Is that wrong? Technically, no, right? Because it would still be a value. It would still give you those values. But we're going to keep it consistent with the steps that we're following here. So for B, again, let's go through and come up with these, the sine and cosine function for each, or for this graph. I'm going to, again, start with the easiest one. I'm going to start with my amplitude. So A is going to be the max minus the min. I can see the maximum up here. I can see the minimum down here. So it is going to be a maximum of 5 minus 1 divided by 2. So I have 4 divided by 2, or 2. So my A value is 2, which again does make sense, because if I'm roughly going for 2, that will also help me find my C value, which is the midline. Now the midline, you might be able to just look at the function and be able to determine it, but in this case my midline is going to be 3. So my C value is 3. I could also determine it by doing the maximum minus the amplitude to get 3. My K value, I'm going to look for a full cycle. Here, it's a little bit hard to determine where the maximum and the minimums are, but not so much for the points along the midline. So if I start here, I continue along a full cycle till I come back to here. So for my period, I'm going to go from here to here. So maybe not the easiest one. And actually, those values aren't even that nice either. So I'm going to go and look for some nicer values. And I do see one here and here. So those are a bit nicer just because they do fall on the grid line. So I'm going to use those. So for my period here, it's going from this section over to here. So from 120 to, if we're going up by 30, so 120 to 210. Right, so my K value, or the period, right, K value is 360 divided by the period, which is 360 divided by the period is 210 minus 120, or the period is 360 divided by 90, which is 4. So my k value is 4. I could also look at how many full cycles there are between 0 and 360, but now this gets a little bit harder, or that gets a little bit harder, because if I look to see where we start at this portion here. So it's not a nice value or a nice portion or segment or area of my periodic function to determine the number of periods, right? I'd be estimating a bit. And we'd want to kind of refrain from doing that just in case maybe the k value isn't a nice value like 4. Now, the last thing we have to do is look for our d values. So again, there are two d values. The d value of sine and the d value of cosine. Now, if I look at these, right, the d value of sine, actually, I think I color-coded these a little bit different on the last one, so let me keep it consistent. D value of sine, d value of cosine. So the d value of sine is starting at the y-axis and going over to the rising portion at the midline. So if I go over to here, this is my d value. This one is easy to see. Right? It's nice and easy to see. It meets on a grid line, so this would be 30. So the d value for sine is 30. Now, if I look at the d value for cosine, right, moving over to the right here, okay, that's my maximum. I don't know exactly what that value is. Right? I don't know exactly what that value is. And I don't want to estimate, I want to be precise. So there is a relationship between the sine and cosine functions where I can figure out that d value. And in this case, to find the d value, it is going to be the d value of sine plus 90 divided by the absolute value of k. And that's just because, again, if you look at the parent function of a sine wave and a cosine wave, you should see that a cosine wave is just a sine wave shifted to the right. Right? We start basically 90 degrees into our sine function. So I can do the similar thing here, except I can't just add 90. I have to be considerate of the fact that the k value might be affecting the horizontal compression or stretch. So I have to take that into account as well. So this would become then the d value for cosine would be 30 plus 90 divided by 4, or 30 plus 22.5. So I get a d value for cosine of 52.5, which, again, that's not something that you would have determined or have been able to get just by looking at the function. So again, you might have to remember this portion here. Actually, I'll do a little summary part at the end. So you might have to remember that portion if you can't easily determine the sine or the cosine d value. So now that I have all my values, I can write out my functions. So y equals, I'll do sine first. So a is 2, so 2 sine, and then in brackets, k is 4, x minus 30 for sine, plus 3. And then for cosine, it's going to be almost exactly the same, 2 cosine 4x minus 52.5, so that's the key difference, and then plus 3. So again, everything's going to be exactly the same except for that d value. And we did just kind of mention, right, if I don't know or I can't easily see the d value or determine the d value in sine or cosine, there is a relationship between them. So the d value of sine is equal to the d value of cosine minus 90 divided by the absolute value of k, and the d value of cosine is equal to the d value of sine plus 90 divided by the absolute value of k. Right? So if you can't easily determine what the d value is in sine or cosine, there is a calculation that we can use to determine that. Lastly, a sinusoidal function has an amplitude of 3 units, a period of 180 degrees, and a max point at 0.5. We want to represent this function with an equation in 2 different ways. So I'm going to kind of at least write out what I know so far for this function, and then I'm going to try to graph it to help determine some of the other values. So I know it has an amplitude of 3 units. So that is telling me the a value. So I know a is 3. I can determine the period or the k value because I know the period is 180. So 360 divided by 180 gives me the period, which is 2. So I know my a, I know my k. My c and my d value. C is going to be easiest one to find because if I go through and I use this max point of 0.5, so let's say, so we got 0, 1, 2, 3, 4, 5. If that is my max point and the amplitude is 3, then that means if I go down 3, 1, or a distance of 3, that is going to bring me to my midline. Which would be my c value, or 2. Now again, different ways you can determine as well. You could do the max minus the absolute value of a, or 5 minus 3, which gives us 2. So that works as well. So I have my a, my k, my c, and my d. Now here, we might want to maybe graph our function or graph as much as we can. If I know that I'm going to have a max here, I know the period is 180, so I'm going to have another maximum here. That means that the middle, or between 0 and 180, at 90, I should be at the bottom. Because if I'm starting at the top here and top here, then the bottom should be 180, or the bottom should be at 90, or my minimum should be at 90, or the middle of my function. And that would be another 3 down. 1, 2, 3. And I can kind of repeat that pattern, or again, if the whole thing is 180 degrees, the middle is going to be at the bottom. Between the bottom and the top, or halfway between that, should be when I'm at 0, or 45 degrees, you might say. And I can just repeat that pattern. So what is it? Each one's 30. Right, so I can roughly graph it out here. I could also look at it as, okay, when is the next, right? I could determine the d value of sine or cosine. I think it was, what did I do for the last one? Cosine was purple. I could go through and find these as well, even if I just graphed the maximums, right? So if I start at my line, or at the y-axis, and I go over to the maximum value, right? I could go over, and I get to a maximum of 180, right? So it's a horizontal distance of 180, so that means the d value would be 180 degrees. And then that means my d value for sine would be cosine minus minus 90 over the absolute value of k, or 180 minus 90 over 2, or 180 minus 45, which would be 135. So different ways we could do it. We could also say, well, if I'm at 0, right, or if my maximum is at 0, what's to stop me from saying that the d value of cosine is equal to 0? That's true. You could do that as well. And then the d value for sine would have to be 0 minus 90 over 2, which would be 0 minus 45, or negative 45. So that would put my d value back here, moving back to the left, which would make sense because that would technically be the closest. Let me draw a little bit better. That would be the closest rising portion from the midline. So I could go back that way as well, right, and keep this as my d cosine. So again, different ways you could do it. We could look at it similar to how we've kind of done already. If we're going over here, that would be your d sine. Right. Again, it's just that idea that there's many different function, or that many different ways we could transform our sine and cosine function to fit this periodic graph because of the periodic behavior. So I'll write out all four, and they all would give us the same graph. So for the first two, we have y equals a, which is 3 times sine times k value is 2, then bracket x plus 135 plus 2, or it'd be y equals 3 times cosine 2x plus 180 plus 2. Or on the flip side, right, if we used a different maximum, y equals 3 sine 2x minus 45. Oh, wait, my mistake. Should be the opposite of what we see. So let me I hope I didn't go back and make that mistake. No, I did not. Good. Okay. So I just want to make sure I didn't make that mistake, which I didn't, which is good, because that means I might have had to restart, or you'd have to go back and fix it. So plus 45 because we're moving to the left, but still plus 2, and then y is equal to 3 cosine 2x. There's no adding or subtracting anything, and then plus 2. So you can see there's a lot of different functions that we could come up with because of the periodic behavior. Technically, they're all right. We wouldn't want to go too much farther because then we're starting to make it very complicated. So it's either we're using the values because they fall exactly on the y-axis, or we're moving to the next one over. I wouldn't do another one and say, well, I'm going over to the next or the second maximum or the third one, which is at 360, and then my d value for sine would be, what is it over here? 360 minus 45, right? I don't want to do that. If I'm going to do or come up with my d values, it's either going to be the values that the very first ones, the closest, or the next one over. But again, you could have different functions that again give us the same sine wave graphically. So a lot of information in this lesson, all revolving around transformations and how to determine the equations based off of the transformations. So it's a little bit more than some of the other functions that we've looked at. but hopefully the fact that it's periodic does make it a little bit easier. Again, remember the key functions are going to be the exact, or the transformations are going to be the exact same, just with different parent functions, because we're dealing with sine and cosine now. But our a, k, c, and d still transform the function the same as they did all the other functions.